Okay, systems of equations. Today we're going to solve them graphically and we're going to solve them using substitution. You should have seen these before last year. We're secondary 3 now. You should have seen them in sec 2. There should have been lots of times that you've done these, but it's okay if you don't remember. So first, a question I get all the time, like, where is this used in the real world? Well, systems of equations are actually used a lot in the real world. They're used for like rate, distance, and time, so you could figure out like the optimal rate that you should go to get somewhere in a certain time or whatever. Planes, trains, and automobiles use systems all the time. You can find the best deal when like renting a car, or the best cell phone plan, or like when deciding on a loan. So like I just bought a house and I could have set up some systems to decide like which loan was the best for me to take. Cost and demand, there's air traffic control so that like two planes don't collide, which would be super bad. The best job for the money, so like if say you had two job opportunities and one you were working less hours but you were making more per hour, the other you're working more hours and making a little bit less, you could figure out which one you're going to make the most money at. Investing wisely, mixing things together to get the right consistency, like in cooking. And I'm sure there's lots of other things. Those are just 10 that I kind of came up with. Let's see some examples of these. So here's one, Pearl and Ivory, which are selling pies for a school fundraiser. Customers can buy blueberry pies and cherry pies. Pearl sold 1 blueberry pie and 10 cherry pies for a total of $106. Ivory sold 6 blueberry pies and 12 cherry pies for $156, and we want to know the cost of each. To find that, we could set up a system. And I guess let's just do that. So let's set up an equation for this. So if Pearl sold 1 blueberry pie and 10 cherry pies, and she made $106 from that. Well, and then Ivory sold 6 blueberry pies and 12 cherry pies and made $156. Well, first, let's let B equal blueberry, because I don't want to write out blueberry in a mathematical sentence, and C equal cherry. So that means 1 of the blueberry pies plus 10 of the cherry pies equals $106. And same with the 6 of the blueberry pies plus 12 of the cherry pies equals $156. Okay. Let's look at another example. We're just setting up equations right now, okay? Let's look at this one. So Aldebaran and Arya, those are my dogs' names, each improved their yards by planting grass, sod, and ivy, which is a lie. My dogs do not improve my yard. They definitely destroy my yard, but in this scenario, this is wishful thinking, I guess, but they bought their supplies from the same store. Aldebaran spent $270 on 12 feet of grass sod and 14 pots of ivy. And Arya spent $96 on 5 feet of grass sod and 4 pots of ivy. And we want to know the cost of one. So I'm going to look at like what information do I know? Well, I know that Aldebaran spent $270 on 12 feet of sod and 14 pots. And Arya spent $96 on 5 feet of sod and 4 pots. So let's let G equal grass sod and V equal ivy. So we have 12G, because 12 of the grass sod, plus 14 of the ivy, so 14V equals 270. And then same thing here, we have 5G, so 5 of the grass sod, plus 4V, so 4 of the ivy equals 96. Okay. One more, we're only doing 3 examples. So the senior class at Corner Canyon and Alta High School planned separate trips to the water park. Say you're going to like Seven Peaks or something. The senior class at Corner Canyon rented 11 vans and 4 buses for 379 students, which is a little bit less than what we actually have. Alta rented and filled 7 vans and 14 buses with 917 students. And I don't think Alta really has 917 seniors, but this is just a story problem. So each van and each bus carried the same number of students, and we want to know how many students can a van carry and how many can a bus carry. So we already know Corner Canyon filled 11 vans, 4 buses for 379 students. and Alta filled 7 vans and 14 buses for 917 students. So let's let V equal vans and B equal buses. So that's going to be 11V plus 4B equals 379. And 7V plus 14B equals 917. Okay. Now, let's actually solve these. So we set them up and we have these different equations. Let's actually solve these. And we're going to first solve them using graphs. Then after we're going to solve them using substitution. And I just want to show you that you get the same thing both times. So let's look at this first equation that we did where Pearl and Ivory were selling pies. Okay. So detour real quick. Do you guys remember how to graph linear equations? I know we went over this prior to this. You should have done this a long time ago, but you might be looking at the screen like, what the freak? There's linear equations and there's not linear equations. These ones up here, notice these are all linear equations because there is no squared, there's no square root, there's no exponents. It's just y's and x's, okay? We just have the two variables. They're all linear. Only the first one's solved for y, but you could solve all the rest of these for y, which means they're all linear. These bottom ones are not linear, and this first one's not linear because of this y squared. Okay, that y squared makes it not linear. Can I make this be like a highlighter? Oh, yeah. So that y squared makes it not linear. That square root right there makes it not linear. That x cubed right there makes it not linear. Okay? So you just have to have y's and x's. We can't have any squareds or anything in there. Because remember, a squared would make it a quadratic. A square root would make it a square root function. A cube would make it a cubic, and that just keeps going. Okay? So here, we can graph these, and the easiest way to graph them is in the slope-intercept form. So y equals mx plus b, where m is always your slope and b is always your y-intercept. And sometimes you need to change the equations to get into this form, but we can do that. So let's just graph one. Like, this is an equation that we were doing before, but let's just graph it. So in this case, so we have y equals 3x plus 2. Well, m equals 3 and b equals 2. So that means my slope is 3 and my y-intercept is 2. Y-intercept, so y is your vertical axis, so I'm going to go up 2 and then I'm just going to draw a point right there. My slope is 3, which I could put that over 1 because slope is always, I don't think I wrote this on these, wrote that on here, but slope is always rise over run. So it's how far up or down you go, and then how far left and right you go. Okay, so the top number is always up and down, bottom number is always left and right. So in this case, we have 3 over 1, so that means I go up 3 and I go over 1. And there's that point. Then I'm just going to do it again, up 3 over 1, there's that point, and then you can draw a line through that. And there is our linear equation, linear line, because if we just ignore the, what's happening, sorry, if you just, it's just a line, so linear line. Linear just means line. Let's do this one. So 1y plus 10x equals 106. Well, we need to get this in the form of y equals mx plus b. So I'm going to subtract that 10 over. And so I get 1y, which can be just written as y, equals negative 10x plus 106. Well, okay, in this case, my m equals negative 10, my b equals 106, which is kind of big, but we can still graph this. So I'm just gonna, it's called Doceri that you can use here. So if you ever need to graph stuff online and you don't have a graph, go to Doceri. Oh my gosh. Go to doceri.com. .com. It's a free graphing calculator online. So this is a graphing calculator and it's super awesome. I use it all the time. Especially if you don't have a graphing calculator, definitely use it. Okay, so I go up 106, and there's my first point. then my slope is negative 10. So remember, I could write that over 1. So that means I'm going to go down 10 and then over 1. And you always just go over to the right. Okay, so you go down 10 over 1, there's that next point. Down 10 over 1, there's the next point. Then I can just draw a line through that. And even though, I mean, this is a super steep line, but that's okay. There's that line right there. It's still a linear graph. Linear just means line. Okay? Let's do another one. So 6y plus 12x equals 156. Well, we have to solve this for y because we have to get it in the form of y equals mx plus b. So I'm going to subtract the 12 over, so I get 6y equals negative 12x plus 156. Divide by 6, and I get y equals negative 2x plus 26. And what I did right there is I just divided this by 6, I divided this by 6, I divided this by 6. Okay. And now in this case, my m equals negative 2 and my b equals 26. So again, I can graph that. I'm going to go up to 26. Now my slope is negative 2, so I'm going to go down 2 over 1. So there's my next point. Down 2 over 1, there's that point, and then I can just draw a line through those 3 points, and there we have it. Okay. So we have these two equations here that we solved. Now, if these were a system of equations, I could put these on the same graph, see where they cross at, and wherever they cross at would be their point that they are equal to each other. So let's just do that. Put them on the same exact graph, and it looks like they cross, I think I just zoomed in. Yeah, I just zoomed in, and they cross right there at 10, 6, which means that the x value equals 10 and the y value equals 6 when we put these equations right next to each other. So if I did 1y plus 10x equals 106 and 6y plus 12x equals 156, if we were to solve those out, you end up getting x equals 10 and y equals 6. Okay. So here, oh, I should have just continued with what, but x equals 10, y equals 6. Well, let's look. So these equations, my green and purple, look very similar to the ones I wrote up there. The only thing is that I let the b's equal y, and I let the c's equal x. Okay, just so I could have the x and the y. Honestly, like in the y equals mx plus b, it doesn't have to be y's and x's. Those are just arbitrary, but that's just what we use all the time. So it's nice to like just refer back. And you can always change the letter of a variable. It's not changing the variable. You're just changing the letter of it. Okay, so that means if x equaled 10 and I said that x equals c, that means c equals 10 and that means b equals 6. So that means each blueberry pie was $6 and each cherry pie was $10. Okay. Let's do another one. So here, let's let g equal x and b equal y. So I'm going to have 12x plus 14y equals 270 and 5x plus 4y equals 96. Remember the mx plus b, so I need to solve this for y. So I'm going to subtract the 12 over, so I get 14y equals negative 12x plus 270. Divide by 14, and I just reduce those fractions, so I get y equals negative 6/7 x plus 135 sevenths. Those are kind of ugly numbers, and I promise I won't give you ugly numbers like this. But we can still graph this. M equals negative 6/7 and B equals 156 or 135 sevenths. So first, 135 sevenths is, it looks like it's about 19 point something. So 19.28, which is why it's right there. And then if my slope is negative 6/7, that means I go down 6 over 7. And then down 6 over 7. So there's my line right there. Okay. Let's do the same thing with the other one. So 5x plus 4y equals 96. Subtract that 5x, so 4y equals negative 5x plus 96. Divide by 4, and you get y equals negative 5/4 x plus 24. So in this case, my m is negative 5/4, my b is 24, so I can go up 24, and then I go down 5 over 4, down 5 over 4, and there is that line. And again, we can see that they cross right there, which is good. We want them to cross, okay? If they cross, that means we have one solution. There will be times they never ever cross. That means that there's no solutions. Or there's also times where you have the same exact line, which means it's infinite solutions. Okay? So they cross right there at 12, 9, which means that x equals 12 and y equals 9. But remember, we let g equal x and v equal y. So that means that 12 equals g and 9 equals v. So they have it's $12 for 1 foot of grass sod. And it's $9 for 1 pot of ivy. Okay, let's do this one. So this is the buses one. Let's say that v equals x and b equals y. Doesn't matter. You could say that b equals y and v equals, or you could say that v equals y and b equals x. Either way, it doesn't matter. So we have 11x plus 4y equals 397, or 379, and 7x plus 14y equals 917. So let's look at the 11x one first. So first we're going to solve this for, sorry, my dog is like right here. We're going to solve this for y, so I'm going to subtract the 11x over. So I have 4y equals negative 11x plus 379. Divide by 4, and you get y equals negative 11/4 x plus 379 over 4. Which 379 over 4 is approximately 94.75. Actually, it's exactly 94.75. So m equals negative 11/4, b equals 379/4, which we can graph that. And I go down 11 over 4. Again, I'm not going to give you an ugly one like this, but I just want to show you word problems so that you could do this if you needed to, okay? And there's our graph. We're going to do the same thing with the 7x plus 14y equals 917. So I am going to subtract the 7x over, so you get 14y equals negative 7x plus 917 divided by 14. So y equals negative 1/2 x plus 131 over 2, and 131 over 2 is 65.5. So that means m equals negative 1/2 and b equals 131.2. So that means the slope is negative 1/2 and the y-intercept is 131/2, which is 65.5. So I'm going to put it up there at 65.5, and then I just go down 1 over 2, down 1 over 2, and there's that graph. We can see that they cross right there at 13 and 59. That means that x equals 13 and v equals 59. Or y equals 59, sorry. But we said that v equals x and b equals y, so that means that 13 equals v and 59 equals b. So that means that each van carries 13 students and each bus carries 59 students. Cool. Let's do, actually, yeah, we want to look at this real quick. So what I was saying before, if you graph these and they end up parallel, so if they end up looking like this graph right here, so you have these graphs and say that and they're parallel. When they're parallel, that means the slope is the same. Okay, so say that you had y equals 3x plus 1 and you had y equals 3x minus 4. So that plus 1, I'd go up 1, draw my first point, and then you'd go up 3 over 1, up 3 over 1, and there's that line. For the 3x minus 4, I'd go down 4, and then I'd go up 3 over 1, up 3 over 1. Since these have the same slope, they're never going to touch, which means there is no solution there. Okay, the one solution is the ones we just did. They only touch once. And then the infinite solutions means that you just have the same graph. So it'd be like you have y equals 3x plus 1, and your other equation was also y equals 3x plus 1. So you'd go up 1 and then up 3 over 1. That's the graph for both of those, which means that it's infinite solutions because no matter what you plug in, they will always be touching each other. Okay. Let's do these now using substitution. Okay. Substitution is when you write it as like It's just like one variable equals whatever it is. So we could get it to be b equals or c equals. And then you just plug it in, and then you continue to solve down. So here, let's look at the green equation. So 1b plus 10c equals 106. Let's solve this for b because it looks easier to solve for b. So I'm going to subtract the 10c, which means I get b equals negative 10c plus 106. Now, I was working with the green equation. I need to use that purple equation also. So I'm going to plug that in to the purple equation. That 12 was supposed to be purple, not green. Sorry. Then we can solve this. So distribute that 6 in. You get negative 60c plus 636 plus 12c equals 156. Get all your c's together. So you get negative 48c plus 636 equals 156. Subtract the 636 over. You get negative 48 equals negative 480. Divide it. You get c equals 10. And then we can plug that back in, and it doesn't matter which equation we plug it into. I'm just going to plug it into, I plugged it into this equation right here since it was solved for b. And you get negative 10 times 10 plus 106, which is negative 100 plus 106, which is 6. And if you go back to the graph that we did, oh, I guess I didn't do it on here, but if we went back to when we did this graph, wherever it is, we did get 6 and 10. Okay. Let's see. Okay, so let's do this one now. So again, I have to solve for one of them. Doesn't matter. I'm going to take that one, and I'm going to solve it for v. You could solve it for g. Doesn't matter. So I subtract that 5g over, and then I divide by 4. So I get v equals negative 5/4 g plus 24. Then I'm going to plug it into the blue equation. And I don't know why the colors are all weird right there. But, so 12g plus 14 times negative 5/4 g plus 24 equals negative 270, or equals positive 270. If you distribute that in, you get 12g minus 17.5g plus 336 equals 270, which is negative 5.5g plus 336 equals 270. Subtract that 336, you get negative 5.5g equals negative 66. Divide by that negative 5.5, you get g equals 12. Cool. And then we're just going to plug it in, and I'm just going to plug it into this equation right here because it's already solved for v. It makes the most sense. So I have negative 5/4 times 12 plus 24, which is negative 15 plus 24, which is 9. Which is, if I went back and looked, that's what we got. It's exactly what we got when we did the other way. So it'd be 12 for one pot of grass and 9 for a pot of ivy. Oh, I think I kept that on there the whole time. Yeah, I did. Duh. So that's double checking our work. Okay. Let's look at this one. So here we have to solve for one of these. I'm just going to solve it for v. So 7v plus 14b equals 917. Subtract that 14 over, and you get 7v equals negative 14b plus 917. Divide by 7, and you get v equals negative 2b plus 131. Now I'm going to plug that in up there. So I have 11 times negative 2b plus 131 plus 4b equals 379. Distribute that 11, you get negative 22b plus 1,441 plus 4b equals 379. So that's negative 18b plus 1,441 equals 379. Subtract that over, you get negative 18b equals negative 1,062. If we did this right, when we divide, we should get 59. So if we divide, you do end up getting 59. So each bus carries 59 students. Could do the same with the van. So v equals negative 2 times 59 plus 131, which is v equals negative 118 plus 131, which is v equals 13, which is what we wanted. Cool. Online learning. Yes. Sorry, this is a little bit longer. it's weird times. So if you have questions, please reach out and ask me questions. Remember, I'm available online. And yeah, hope you're all doing well. Bye.